when a certain grocery store opens, it has 50 pounds of banana on a display table. Right away, they give you initial quantities. So you better underline that or something. Customers remove bananas from the display table at a rate modeled by. I would consider that my rate out, correct? My removal rate. So sometimes I'll write that next to the function, where f of t is measured in pounds per hour and t is the number of hours since the store opened. After the store is open for 3 hours, employees start adding bananas. So this would be my rate in. Now, are they adding bananas when the store opens? No, they're not adding anything until 3 hours later, right? And we see that also after the function, they say 3 is less than t, which is less than or equal to 12. And so how many hours is the store open? Well, it's open for 12, right? Let's see here, how many pounds of banana were removed from the display table after the first 2 hours the store has been open? Now, the wording is a little weird, right? So I just say how many pounds of bananas were removed during the first 2 hours, basically, right? So what they're kind of getting at is after the first 2 hours, after hour 2, how many bananas were removed from 0 to 2, basically, right? So I think that's what you guys wrote out, right? Calculator active problem. So we're writing down what we're going to do, and then we're going to do it. So for 2017, number 2, part A, we got, antiderivative, 0 to 2. Removal rate, go back and read if you need to. That was F, so F of t, dt. And then we use your calculator. And I think you guys got 20.051, correct? Then a little concluding statement, 20.051 pounds of banana removed from the display table during the first 2 hours the store is open. Okay, just word it how they worded the question. Word your response how they worded the question. Questions with that? Do I need to write that out, or you guys got it? Did you guys already write a response? Okay, part B. Find f prime 7. Okay, now this is one place where they're asking you to do two things, right? One of them is the mechanical, one of them is explaining. Using correct units, explain the meaning of f prime 7 in context of the problem. Now, if f is the pounds per hour that bananas were being removed, what would the derivative of pounds per hour be? Okay, so pounds per hour, right? When you find the derivative, you divide by another time unit. So that would be the rate at which bananas, the rate of the rate, I should say, right? The rate of the rate at which bananas are being removed. Again, this is a calculator problem, so we're writing down, we're finding f prime 7 equals, and I think that's what, 8.119 or 120. So then what I would say is after the store has been opened for 7 hours, the rate at which bananas were being removed from the display table is decreasing. You have to say decreasing by -8, or I should say decrease. Since we said decreasing, we don't have to say negative. It's decreasing by 8.119 pounds per hour, or pounds per hour squared. Did anybody do this? Which is less than 0. Did you guys do that? Good stuff. Okay, questions on part B? This is the rate of the rate, so pounds per hour. Part C is the number of bananas. So this is the quantity now. We thought, like, we've done these problems before. This is the quantity part. Is the number of pounds of bananas on the display table increasing or decreasing at time t equal 5? Now this is just number of pounds, increasing, decreasing. That just means you look at the derivative of number of pounds, which is the rate of removal or adding on, right? You have to consider both. And so you don't have to find the derivative. You don't have to find the integral. You're just saying rate in minus rate out at 5, right? So rate in is G, rate out is F. Plug those two in your calculator. Now, what you could do, since you probably have F and Y1 and G, Y2, you would say, you just go to your table maybe, plug in 5, and then write down the numbers and subtract them, carry the decimals as far as you can. That's fine. Or remember, you can say like Y2 of 5 minus Y1 of 5 from your home screen. And that answer turned out to be negative 2.263. Is that right? And then state the obvious, which is less than 0, because that is important, right? So then I would say the number of pounds of bananas on the display table is decreasing at time t equal 5. And then I would definitely say because G of 5 minus F of 5 is less than 0. That would definitely be my reason. State the obvious. Ms. Molly already stated up here. State it again in your conclusion. Okay? Well, we haven't had to find the maximum or minimum number of bananas on the display table, have we? That's fine. Another thing they would ask us is the amount of bananas at a particular time, which that is part D. How many pounds of bananas are on the display table at t equal 8? All right, well, that'd be the initial quantity plus rate in. Now, rate in is G of t, right? Antiderivative G of t dt. But what are the boundaries on G of t? 3 to 8. Why is it only 3? Yep, that's where they're trying to make you guys make a mistake. They're trying to make you put 0 here. Okay, because all the other ones we did rate in minus rate out in one antiderivative because the boundaries are the same. They pulled a sneaky one, a fast one on us, and they changed the boundaries here because they're only starting to add bananas to the display table after the store has been open for 3 hours. Minus, well, these people have been taking bananas since the store opened, 0 to 8, f of t dt. So yes, you do need 2 antiderivatives for this one. And is it 23.347? Like that. Okay, so then I would say 23.347 pounds of bananas are on the display table at time t equal 8. And part D is worth 3 points. You get 1 point for each integral. So that's nice. Okay, any questions? How do we do? If you're scoring yourself, did you score over 6 points on this one? Hopefully. All right, let's go to 2015 then. Number 1, calculator active. The rate at which rainwater flows into a drain pipe is modeled by the function r. So this would be my rate in, where r of t is measured in 20 sine of t squared over 35 cubic feet per hour, because that'd be the volume of water flowing into something per hour. T is measured in hours for 0 to 8. The pipe is partially blocked, allowing the water to drain out the other end of the pipe at a rate modeled by d of t equals and a fairly convenient polynomial, right? But there's decimals in there, so that'd be your rate out. And that is okay for 0 to 8 also, so they're both good for 0 to 8. There are 30 cubic feet of water in the pipe at t equals 0, so we have initial quantity. Well, what are they going to ask us? How much water flowed into the pipe? How much water flowed out of the pipe? What's the amount of water in the pipe at a certain time? What's the maximum amount of water in the pipe? What's the minimum amount of water in the pipe? Is the water increasing or amount increasing or decreasing? So the rate of the rate increasing, decreasing. There could have been a number of different things, but that's about it. Okay, let's see what 8 has to say, or A has to say. So this is 2015, number 1. Part A. How many cubic feet of rainwater flow into the pipe during the 8-hour time interval 0 to 8? Okay, R of t is rate in, correct? So let us just be antiderivative 0 to 8, R of t dt. 1 point for integral, 1 point for answer, guys. We're already at 2 points. You're halfway to average. And do we get 76.570? Including statement. 76.570 cubic feet of water flow into the pipe during the 8-hour time interval 0 to 8. And you could write the time interval the way they did in the question. That's fine. Part B. Is the amount of water in the pipe increasing or decreasing at t equal 3? Did they ask about the amount or did they ask about the rate? They said amount, right? So that just means you look at the derivative of amount, which is rate, which they gave us. Okay, so we figure out what is the rate in at 3 minus the rate out at 3, and let's see what that is. So rate in at 3 minus rate out, which would be d of t, right? D of 3. And let's see what that equals. And you get 1 point just for considering R of 3 and D of 3. What do you guys got for number?
1.035. -0.314.
Yeah, negative 0.313 or 4. Now, does the negativity of this answer matter? Definitely. So let's state the obvious, which is less than 0. Okay. And our concluding statement: the amount of water in the drain pipe, or I should say the amount of water in the pipe, the amount of water in the pipe is decreasing at time t equal 3. And t is in hours, right? We could say t equal 3 hours. I'm going to do that because R of 3 minus D of 3 is less than 0. Now, if they would have said, is the rate at which the water flowing into the pipe increasing or decreasing, you would definitely have to look at R prime of 3 minus D prime of 3, right? Yep.
Can you show me how to type R3 minus Q3? Because I did it, and I got that answer, but I just...
So what I would do, since do you have y1 and y2 in your calculator already?
Yeah.
There's 2 ways to do it. Go to your table, plug in 3. Obviously, this is not the right function. Look at your y1, look at your y2, write them down, subtract them. Carry on as many decimals as you can. Okay, that's one way to do it. The other way to do it would be to go alpha y1 evaluated at 3. That'd be your rate in minus alpha f4 or y2 evaluated at 3, and then go like that. Obviously wrong equations, but make sense? Okay. Alright, part C. I hope they're not asking us max or min problem. Oh, look at that. Minimum. At what time 0 to 8 is the amount of water in the pipe a minimum? Justify your answer. Guys, like I said, yesterday, easy dubs, man. This is a candidates test problem. You're given rates already. It's not much different than what we've done before, right? So, candidates test, what are we considering? We're considering when the rate in minus the rate out equals 0, which, check this out, guys. If you add dt to the other side, you're looking for when the rate in minus the rate, or when the rate in equals the rate out. So all you have to do on the interval 0 to 8 is look for when your two functions cross. That's all you have to do. Yesterday I made you guys write in y3. I made you write y1 minus y2 and y3 and look at that graph. Well, this is the easier actually. Okay, what's our t value for this? What'd you get? 3.271. You guys got confirmation on that? Yep. Okay. There would be our critical number. Now let's enter in our endpoints and our critical number. Now, did you guys store this as A already? There's our T. Now, we have to figure out the amount of water. Okay, guys, how much is in the pipe at the very beginning? 30. So we don't even have to really do any work for that one. Okay, now how are we going to figure out how much is in the pipe at 3.271? Also carry on more decimal places, right? Don't round in the middle of the problem. That'd be 30 plus the antiderivative. Since the rate in, it starts from 0 to 8, the rate out is 0 to 8. We can combine these into one antiderivative. And is it okay if I put t up here? That means we can plug in 3.271 for one, and then we can plug in 8 for the other. And that would be r of t minus d of t dt. Okay, figure out the amount at 3.271 with some change. Figure out the amount at 8. Let's put those numbers in our table. Now, unlike the fish problem, they did not give us the amount of fish in the lake at the very beginning. It doesn't matter, but since they did give us the amount in the pipe at the beginning, we should include it. When you guys got a number, let me know. Be brave.
I got 27.964.
That's right. And then?
48.5.
So then obviously, when is the minimum amount of water in the pipe? At the critical number we found at 27. Every once in a while it's at the endpoints, guys. It hasn't been yet for us, but every once in a while it is at the endpoint. So be careful. So the amount of water in the pipe is a minimum at time t equal 3.271 or 272, and then hours is the units. Now, justification, remember, justification is always the T-chart for max min problems. Okay, candidate sets problems. All this work, this setup, that's all our justification. We are demonstrating a lot of good stuff here. All right, now part D. I don't think we've seen one like this, but let's see if we can figure it out. The pipe can hold 50 cubic feet of water before overflowing. So that's an amount of water. So we're probably going to be finding the antiderivative of the rates for this one. For t greater than 9, water continues to flow into and out of the pipe at the given rates that they already gave us until the pipe begins to overflow. So water is still going in, water is still coming out, but you know, it has 48.543 gallons of water at 8 hours. At 50 cubic feet, it starts overflowing. So write, but do not solve an equation involving one or more integrals. These are my favorite. That gives the time W, the pipe will begin to overflow. People overcomplicate this too much. How do you figure out how much water is in the pipe? Well, it's this, right? That has to equal 50, right? That's our equation. 30 plus antiderivative 0, but I'm not using T. What should I use? What they tell us to use? W, yeah. That has to equal 50. That's it. 2 points. Now, up here, guys, do you guys see anything wrong with my integral setup that could be considered wrong? What about this? The bounds of integration should not be the same as the integrand, right? You could put an X up there. It's a sideways T. It's an X, right? So I don't think it's too terribly crazy to worry about, but okay, next one. We got plenty. We got 25 minutes already. That's crazy. This one, I have never done this problem before until this morning. I've been saving it. So I've never done this problem before. Let's see what happens. A large tank contains 40 gallons of water at time t equals 0. Okay, I'm already thinking rate in, rate out problem. During the time interval 0 to 2 hours, water is being poured into the tank at this given rate. Okay, during the same time interval, okay, 0 to 2, I like that, so I don't have to write two integrals. During the same time interval, water is leaking from a small hole that is being fixed. The rate that water leaks out is given by blah, blah, blah gallons per hour. How much water has been poured into the tank after 2 hours? That would be just the rate in, correct? And we understand the wording now. When they're saying after 2 hours, they mean when from 0 to 2 hours, what is the accumulation of water poured into that tank? 0 to 2, W of t dt. I do not know the answers to this one. What do they call that? A premiere? We're premiering this problem? I don't know. 0.6. I do not have this answer key written out. I will after this period though. To the, what, x squared? Then minus 1? Is that right? Mm-hmm. While I'm at it, I'm just going to put the rate out right away too.
Oh, it's raised to the x squared minus 1.
Oh, geez, that minus 1 should be up in top, right?
Mhm.
All right. Stay up there. There we go. Minus 1. Okay, get rid of this. Delete. Cool. Now those look right. 6 cosine of 0.7. 0.7 seems familiar to us. That was a rate out the other day. That was a constant rate out. This is not a constant rate out. Okay, got that ready. I'm in calculus mode, right? So math 9, boundaries 0 to 2, y1, x, like that. Are we good? (631) or 632 would be acceptable. So I will put 3.631 gallons of water were poured. I can say have been poured, that's fine too. Into the tank after 2 hours. You could say on the time interval 0 to 2 hours. That's fine also. Okay? Part B. How many people have this done already? Do you have some done? Some, huh? Pretty close? Alright. Find the time on 0 to 2 hours when the amount of, oh my gosh, water in the tank is a minimum. Justify your answer. Right away, what are we looking for? When the rate in minus rate out equals 0. That means when the rate in equals the rate out. So from this particular case, WT minus L of T equals 0. So in graphically, calculator, I can look for when WT crosses L of T, and make sure your window is just 0 to 2. You don't want to see all this extra garbage in there. 0, yeah, I got 300 in there already still from the other day. Negative 10, positive 10, let's see if that works. A little exponential, that's being expected. Then we have what, a cosine graph? Yep. Look at that, there's our critical number. Go to calculate intersection. Hit enter 3 times. And 1.580, I'm just going to write that down just so I don't forget. And you can write all the decimals out if you want to. That's fine, guys. I'm going to quit. And what do we do right away? Store that number. There we go. Now I can just type in A on my integral because we know we're going to have to do that. Okay? So we have critical number 0 or endpoint 0, critical number 1.580825017, and then we have endpoint 2. The amount of water, or what does it say? Yeah, water, is calculated by taking the initial quantity plus the integral from 0 to whatever value we have of WT minus L of T dt, parentheses around the whole thing. I can put an X up here and put an X right here if you want. It doesn't really matter, guys. I like to write this down so that I know what to type into my calculator. And the more often you guys see this, the more it's ingrained in your brain, and you're not surprised by a question like this. Okay, so then I got 40 plus math 9, 0. I'm not doing 0, why? Because how much is in the tank initially? Yeah, 40, so I can just fill it in. I'm going to type in my A. Okay, now it's going to be Y1 minus Y2 Think about this, guys. Nobody ever showed me how to access these Y1s and Y2s ever. I always had to write out or type in the function all the time. We didn't know how to do this stuff. But we were very good at going and highlighting and then going and changing, because once you type it in once, you don't have to type it in again. Oh, I don't need 8. What do I need? 2. Yeah, seriously, Bonnie, figured out. 33.424. That's the other thing. Like, I'll type stuff in, and then I'll go back and kind of look over things while I was computing. I say, oh, I needed 2, not 8, because 8 was the previous problem I was working on. Again, sometimes after 3 hours of taking this test, your brain is mush. No excuse, though. Figure it out. 0 to 2. 35. Is this what you guys are getting? Okay, so when is the minimum amount of water in the tank? Well, it's at time 1.580, right? Again, it happened at the critical number. It could happen at the endpoints. Okay, the minimum amount of water in the tank. Amount of water in the tank occurs at time t equal 1.580, and then what's my time unit again? Hours. Okay. Part C, you guys already working on it? I think this repetition really helps. Is the amount of water in the tank the amount of water in the tank? This is the easy one because they already gave us the rate. All we have to do is check to see what that rate at 1 is equal to. So rate in is W of 1 minus L of 1. See what that equals. Okay, so I'm going to go alpha F4, Y1, evaluated at 1, minus Y2, evaluated at 1, enter. Is that what you guys got? Negative 3.989. Does the positivity or negativity of this answer matter? Yep, so we better say less, which is less than 0, state the obvious. Okay, again, if you don't remember how to do that, just go to your table, plug in 1. You can highlight that number, it's 0.6. Highlight that number, subtract, right? You can write that number down real quick. Write 0.6, then minus 4.5890531231. Type those in real quick, hit enter, and you'll get this number. That's fine. So the amount of water in the tank is decreasing at time t equal 1, that'd be hour, right? Because W of 1 minus L of 1 is less than 0. Maybe 2 points. You might get 1 point for considering W of 1 and L of 1 and 1 point for the answer. All right, let's see what part D has us doing. Never seen this before in my life. The tank holds up to 300 gallons of water. For T greater than 2, water continues to be poured into the tank at a rate of WT. So we still have the rate in at WT. However, water leaks out of the tank at a constant rate of 1.02 gallons per hour. after t equals 2. Okay? Set up but do not evaluate an equation involving one or more integrals that could be used to find the time w when the tank first becomes full. What do you think we got to do with that one? I want you guys to write down, what do you think we got to do? You guys already do it? Nelson?
Yeah.
What do you think?
So you're gonna be setting up two integrals here. One of them.
Why?
Is,
Why 2?
so you're gonna have the original integral, which is integral 0 to 2 dt minus lt, or lt. And we already know the value of that one, so if you want to change that to a constant later, that's fine.
Okay, do we need to change it to a constant though? Is it okay to leave it as 40 plus integral 0 to 2 w of t minus L of t? Is that okay to leave like that?
I think that'd be fine. Yeah.
Okay.
And then you have the other integral. Since the leaking now changed, you have to change the LT, which is now going to turn into integral 2 to W in the last question.
2 to w?
Yeah.
And I like how you said in the last question, because now we know, like, they're talking about w. Like, where do we put w? What's the time unit? That's a boundary then. Okay.
Okay, WT minus the new leaking constant, which is 1.02.
Leave it like this or put a t after it?
Yeah, leave it like that. In parentheses, dt equal to 300.
We're missing a sign between right here. What's this sign?
Plus.
Plus. Yep.
And then I messed around and I basically just so the WT2 to W is equal to a constant that is 4.
Okay. Do we have to do that?
Yeah.
Okay. Is it okay if we do? Yeah, it's okay if you do. If you subtracted 40, that's okay. If you left those two over there by themselves, that's okay also. If you wrote out 4 integrals, that's okay also. 0 to 2 w of t dt minus 0 to L of t dt plus 2 to w w of t. And honestly, you could have went 0 to w of wt dt and then minus 0 to 2 L of t dt plus minus 2 to w 1.02. That'd be fine also. I don't think many people would think about it that way though. This is what I would have wrote. Is it wrong? No, it's right. These are my favorite. You have to write them out. You don't have to do anything. I like that. This problem's not too bad, guys. If I would have gave this problem to you guys last week, would you be able to figure it out like this? No. I mean, it helps going through these. You learn the patterns. You know what to do. You know what to write out. You know what they're looking for. We know the calculus, but the practical application of calculus, which is the FRQs, that's a little struggle sometimes. That's why we spend a lot of time going over these. And that's why I wait till towards the end of the year to go over these, because we would have forgotten this stuff if I would have been going over this in September, right? We would have forgot it by now. But we know calculus. I always have to work on the practical application. Ms. Bond, do they do this stuff in the actual job? Yes. Except for the computers do all the work for you. Any questions?